Greetings, my dear students. I am Dr. Rafi Rabi. I am a physics teacher. I am a physics teacher by passion as well as by profession. My teaching range starts from undergrad, from 11th class to the postgraduate classes. I am a professor by profession as well. I am teaching 11th and 12th classes, NEET classes, JEE classes. I am interested in teaching competition level physics to any class, whatever is available. My aim is to make the subject which students often find difficult. My passion, my aim is to make the subject easy and interesting. Students should fall in love with the subject, then only they can excel in the subject, they can solve numerical problems. I like to clear the concepts of the students and train them in solving the numerical problems. Today I have chosen a simple topic, distance and displacement. This is for 11th or NEET classes. I have chosen this topic for this demo. So, what is distance? Distance is the actual path traveled by a body from point A to point B. For example, a body is traveling, it starts from point A and it moves to point B. Along this path, this red dashed curve, this is the actual path by which the body moves from point A to the point B. If I measure this path, this will give me the total distance traveled by the body. If I measure this dashed line, the total length of this dashed line, this will give me the distance traveled by the body. However, if I measure the shortest distance from A to B, that gives me the displacement. So displacement, here you can see it's the minimum distance from the initial point to the final point. While as distance is the actual path that's traveled by the body. The body has initially its position vector is at A and its final position vector is at B. The displacement is the subtraction of the position vectors. So this is the displacement, the shortest path from between the initial point and the final point, but the distance is the actual path. You can understand this in a more clear way using this example. This smart boy, he starts from A, he starts his journey from A, moves to B, then moves to C, then moves to D, then back to A. Let me check how much distance he has traveled. That is 5 plus 3 is 8, 5 plus 3 is 8, so total distance is 16 meters. This is the total distance traveled by the body. But can you tell me the displacement of total net displacement of the boy? The boy has started its journey from point A and it is back at point A, so net displacement is 0 because initially the position vector of the boy was here and final position vector of the boy is again here, so the net displacement of the boy is 0, but the net distance, the total distance traveled by the boy is 16 meters. My dear students, let me quote another example by which you can understand the concept of distance and displacement in a more clear way. It is given that a particle moves on a circular path. This is a circular path, the particle moves on it. It completes one revolution in 40 seconds. Suppose it starts from this point B and it takes 40 seconds to go once around the closed path. Calculate the distance and displacement in 2 minutes and 20 seconds. 40 minutes, the particle takes 40 seconds in completing this circle. We have to find the distance and the displacement in 2 minutes and 20 seconds. So first let me convert this 2 minutes and 20 seconds into seconds. So it is 2 minutes is 120 seconds plus 20 seconds, so that is equal to 140 seconds. So how much distance is traveled by the particle? So in 140 seconds means 120 plus 20 seconds. You can see in the particle takes 40 seconds to make one revolution. So in 120 seconds, how many revolutions will it make? In 40 seconds, one revolution. In 40 seconds, one revolution. In 40 seconds, one revolution. So that means in 120 seconds, it will make 3 revolutions. And in 20 seconds, in 40 seconds it makes a complete revolution, and in 20 seconds it will make half revolution. So the particle will reach from point B to point A, So what is the total distance traveled by the particle? You can see that in one revolution the particle travels a distance of a complete circumference, so that is 2 pi r. So that is 2 into 3 into 2 pi r plus 1/2 of revolution. So a complete revolution is 2 pi r, 1/2 of a revolution is pi r, so this will become, so it is 6 pi r plus pi r, so that will be equal to 7 pi r. This is the total distance traveled by the body in this time, 2 minutes 20 seconds, which comes out to be 140 seconds. So the total distance traveled by the body is 7 pi r. The value of pi we know. If the radius is given, we can calculate the total distance traveled by the body in this total time. But what is the displacement? You can see after 3 complete revolutions, the particle will be back at point A. So in this half revolution, the particle will move from point B to point A. So that means the displacement is this diameter, and you know, if this is radius, so the displacement is 2r. So the displacement of the particle is 2r. So the displacement is 2r, and the distance is 7 pi r. Okay, let me quote another example. A body moves, this is a car that moves from point O to point D along this, O to A to B, B to C, and C to D. We have to find the total distance traveled by the particle and the total displacement. Total distance is simply 8 plus 4 plus 4 plus 8. So that is 12 plus 12, so that is 24 meters. That is the total distance. But how can you calculate the displacement? Since displacement is a vector quantity, so we have to take care of the direction as well. Suppose the particle that is mentioned in this question first moves from O to A. Let me take this as x-axis. So if I write in this displacement vector, this displacement in the form of a vector, I have to find the total displacement vector, that is this OD vector, because this the particle is initially at point O and finally at point D. So this OD, that will be the position vector, that will be the displacement vector, So this OD, that will be equal to, this is 8 kilometers along positive direction of x-axis, so that is 8I. Now the particle moves from A to B, but along the negative y-axis, and you know that the unit vector along y-axis we take as j cap, but the particle moves along the negative direction of y-axis, so it is minus 4j. And then the particle moves from B to C back, that means along negative direction of x-axis. So if this direction is positive, this is negative, so this is minus 4I, and the particle moves in the positive direction of y-axis 1 kilometer distance, so plus j cap, right? So it will be equal to 4I, 8I minus 4I, that's minus 3j. So this will be the displacement vector of the particle, 4I minus 3j, so that is this displacement vector OD. You can find the magnitude of the displacement vector as, so that is under root of 4 square plus minus 3 square, so that is equal to 16 plus 9, so that is equal to under root of 25, so that is 5 kilometers. So the displacement of the particle is, the magnitude of the displacement is 5 kilometers and the distance is 24 kilometers. You can now find the direction of the displacement as well. How you can do that? You just plot this vector. This is 4I minus 3j. This is 4I, that means 4 kilometers along x-axis, minus 3j, so that is 3 kilometers along negative direction of y-axis. So if you find this angle, this angle, theta, so this is 3 kilometers. You can here see that tangent of theta, that is equal to perpendicular, this is perpendicular, so this is 3 divided by 4. You know that tangent of theta, that is equal to 37 degree, so theta is equal to tangent of theta, so that is equal to 3 by 4. You know this triangle, so this is, if this is 37 degree, this is 3, this is 4, and this is 5. So the angle is 37 degree, this theta is 37 degree. So I can say that the direction of the magnitude of the displacement is 5 kilometers, the direction of displacement is 37 degrees towards, this is south, this is north, this is west, this is east, towards south of east, south of 37 degree towards south of. This gives me the direction of the displacement vector of this car from O to D. Thank you very much.